The second method of writing the sets here is rule method, or it is also called as a set builder form. So here are some rules how to write a set by rule method. In this method, elements of a set are represented by a small common letter. A vertical line or colon is given after it. Then the property under which all elements are collected is written. Let us understand this with the help of some examples. Here is the first example, a set of vowels in English. This set you have written by listing method also. So you know that one, there are 5 vowels in English: A, E, I, O, U, and by listing method we have listed all these vowels. But here by rule method, how this set is written, first of all we give a name or capital letter. We denote the set by capital letter from A to Z. So this is set P equals to in curly bracket. Look, in this method elements of set are represented by a small common letter. I have taken here a small common letter as X, and a vertical line or a colon is given after it. Here is a vertical line. What the X is a vowel in English. Means X may be A, may be E, I, O or U. So all these vowels are represented by a single common letter X. Here is the second example. Z is a set of these colors: violet, indigo, blue, green, yellow, orange, red. These are elements of the set. If you observe this one, all these colors are part of a rainbow. So here is the set Z equals to, in curly bracket, small z. Elements are written by a common small letter. A vertical line. What the Z is a color in rainbow. So Z may be violet, it may be indigo, blue, green, yellow, orange or red. So these elements are represented by a small common letter, and then a rule is written by which all these elements are collected together. Next example, here is a set T and its elements are 6, 12, 18, 24, 30, 36. If you observe, all these are the multiples of number 6. 6 ones are, 6 twos are, 6 threes are, 6 fours are, 6 fives are, 6 six are. Means these are first 6 multiples of 6. So we have to write down it by a rule method. T equals to, in curly bracket, small t, a common letter used to denote or represent all these numbers. What these numbers are? These are multiples of 6, means t equals to 6n, where n is a natural number, n belongs to n, and up to which number? These are first 6 multiples, so n less than equals to 6. So n is natural number, less than 6 are 1, 2, 3, 4 and 5 equals to 6. Means here 6 ones are, n is 2, 6 twos are, n is 3, 6 threes are, 6 fours are, 6 fives are, 6 sixes are. Okay, so instead of writing in words, we have to use some mathematical signs and symbols to denote this one. The next set is M, and the elements of set are -3, -2, -1, 0, 1, 2. If you observe, all these numbers are integers, negative integers, 0 and positive integers. Okay, so M is a set where M is element of set and M is an integer. But which integers? From -3 to 2. So M greater than equals to -3 and less than equals to 2. Means these elements are integers from -3 to 2. Next set is K. Elements are 1, 4, 9, 16, 25, 36, 49, 64. If you observe these numbers, okay, all these are squares. This is square of 1, this is a square of 2, 9 is square of 3, 16 is a square of 4, this is square of 5, square of 6, square of 7 and square of 8. So K is a set where Y is element of set. So elements are generated by a common small letter y, vertical line, y equals to n square. All these are squares. Squares of natural numbers up to 8. So n is a natural number and n is less than equals to 8. Okay, natural numbers less than 8 are 1, 2, 3, 4, 5, 6, 7 and equals to 8 means this is the 8th number. Okay, so n may be 1, 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64. This is one more set. P equals to, in curly bracket, these are elements 1, 8, 27, 64, 125. If you observe, all these are cubes of natural numbers up to 5. So P is a set where x is a element of set, x equals to n cube, n is a natural number up to 5 means 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125. In this way you can represent the sets by rule method. Next point into it is types of sets. First is singleton set. A set consisting only one element is called a singleton set. Second type is empty or null set. A set having no element is called empty or null set. For example, suppose y is a set of elements where y is a common element, y belongs to n and y less than 1. So there is no natural number less than 1 because the smallest natural number is 1, means this condition does not exist, means it is empty set and it is denoted by a blank curly bracket or a letter phi. This is a Greek letter, it is called as phi, phi. Next set is finite set. When elements of a set are limited and countable, it is called finite set. And fourth type is infinite set. When elements of set are unlimited and uncountable, then it is called infinite set. Let us understand all these with the help of some examples. Here is the question: classify or identify the following sets. So this is set A. It is written by rule method. X is element where x is a natural number and x is an odd number, means this is a set of odd natural numbers. Suppose we write it by listing method, this would be the list: A equals to 1, 3, 5, 7, 9, 11 and so on, means elements of this set are uncountable, so that's why this is a infinite set. In the same way, set of natural numbers is also infinite set. Set of whole numbers, infinite set. Set of integers, this is also infinite set. Next set is B, where x is element of B, x is a natural number and 3x minus 1 equals to 0. So we have to find out here for which value of x the equation becomes 0. So 3x minus 1 equals to 0. 1 is transposed here, minus 1 becomes plus 1, 3x equals to 1. 3 is multiplied when we transpose x equals to 1 upon 3. But the condition is given that x is a natural number and this is not a natural number, means B is empty set or null set, and empty set is also finite set. Here is one more example. E is a set where x is element of E and x is a capital of Maharashtra. So which is capital of Maharashtra? Mumbai city. There is only one element, so it is a singleton set and elements are countable, that's why this is a finite set also. G is a set where x is element of G, x belongs to I means x is a integer and x square is 100. Okay, and there exists such two numbers minus 10 and 10. Minus 10 square is 100, 10 square is also 100. So these elements are countable and limited. So this is also a finite set.